بسم الله الرحمن الرحيم. السلام عليكم. I am Professor Adam Ahmed Adam. You are welcome to Immunology module. This module belongs to microbiology course. Immunology is a science of the physiology and pathology of the immune system. This means it is the scientific study of the immune system in health and disease, and there are other applications, as we are going to see in the scope of immunology. The scope of immunology, the areas that are covered by immunology: one, the physiology of the immune system; two, pathology and pathogenesis of some diseases; three, laboratory investigations; four, immunotherapy; five, industries of some medicines and vaccines. The components of the immune system. The immune system is composed of one non-lymphoid component, two lymphoid component. We talk about the non-lymphoid, arrow to the upper part. The non-lymphoid component is mainly responsible for innate, which is the natural immunity, the innate immunity, which is the natural immunity. It is composed of barriers like skin, mucous membranes, secretions, cells like the natural killers and phagocytic cells, and so on. We come to the lymphoid component. Here, the lymphocyte is the key cell in the lymphoid immune system. The lymphoid immune system is composed of primary lymphoid organs and secondary lymphoid organs. So look at the red arrow below and the green arrow to the right and the brown arrow to the left. The primary lymphoid organs, here we are going to find the lymphocytes in an immature state, immature lymphocytes. There are two organs in the primary lymphoid system. The primary lymphoid organs are the thymus, which is the site of the T cell maturation. As you know, the thymus is a retrosternal gland. Bone marrow, this is a site of blood cells production and B cell maturation. When you find here the word cell, by the word cell, we mean lymphocyte. So we can say T lymphocyte or B lymphocyte. Now we go to the secondary lymphoid organs. Here we are going to find the mature lymphocytes. And the organs are many, secondary lymphoid organs are many, such as lymph nodes, spleen, mucosa-associated lymphoid tissues, tonsils, and so on. The mature lymphocytes are found in the secondary lymphoid organs. The lymphoid immune system in general, its function is mainly acquired immunity. And still there is an interaction between the non-lymphoid and the lymphoid components. Functions of the immune system: protection of the body against foreign antigens, antigens that are not part of the body. The foreign antigens are: number one, pathogens. Pathogens are disease causing living organisms like bacteria, viruses, parasites, and fungi, in addition to their products that can cause diseases such as toxins. Two, effete and dead body cells. The non-functioning or harmful body cells, that is say maybe the infected body cells. So the aged cells or dead cells or infected cells by viruses should be removed by the immune system. Three, tumors. These are neoplasm, abnormal growth. The immune system guards against their development. Four, immunogenic non-living agents that are harmful to the body, like allergens. Allergens are antigens that can cause hypersensitivity reaction. Immunity. Immunity is the ability of the immune system to protect the body against foreign antigens. Functionally, it can be passive immunity or active immunity. The passive immunity is offered ready-made to the body. That is given to the body ready-made. The passive immunity can be natural. The best example of the natural passive immunity is the immunity gained by the baby in the uterus of a pregnant woman after passing IgG from the pregnant woman to her baby in the uterus. So the pregnant woman produces immunoglobulin G and then transfers this immunoglobulin across the placenta to her baby in the uterus. The immunity gained by the baby is natural passive immunity. The passive immunity can be artificial, man-made, not natural, man-made. This occurs when there is administration of ready-made immunoglobulins against different types of infection, maybe against tetanus, rabies, hepatitis B virus infection, and so on. So these immunoglobulins are produced outside the body, maybe in the factories or laboratories, and then transferred to people. The immunity gained after receiving these immunoglobulin is known as passive artificial immunity. Active immunity. This is self-made. Two types. One, innate immunity, also known as natural, basic, and non-specific immunity. Two, acquired immunity. This is gained by the body after antigenic stimulation to the immune system. It is also known as specific and adaptive. I would like to mention here that the innate immunity is non-specific in function. It acts or protects the body against a wide range of different antigens, while the acquired immunity is specific. Each component is specified against a specific antigen. Innate immunity. Basically, it equips the body. That is to say, it is part of the anatomy and physiology of the body. It is non-specific in function, as I have just mentioned. It is the first line of immune defense. The components of the innate immunity. The innate immunity acts through these components. One, barriers, skin, mucous membranes, cilia, the beating cilia in the upper respiratory tract, and also other components. Two, normal microbial flora, harmless bacteria and fungi found in the body, mainly in the skin, GIT, mouth, vagina, and so on. They do not cause diseases to the person except in certain situations, but they prevent the pathogens from causing diseases. Cells to cells. These are natural killer, which are granular lymphocytes, phagocytic cells like macrophages and neutrophils, for secretions, different secretions like milk, saliva, mucus, tears, gastric, hydrochloric acid, and so on. 5. Complement system through the alternative lectin pathway. We're going to talk about the complement system in a separate lecture. The lymphocytes. These cells are the essential cells in the lymphoid immune system. We are going to mention the natural killer. This is a granular lymphocyte which is acting mainly in the innate immunity. Its function is killing of virally infected cells. Helper T cell, its function is the acquired immune response. Cytotoxic T cell, its function is killing of virally infected cells and transplant rejection. Regulatory T cell, its function is regulation of the immune response, immunoregulation. B cell, its function is production of antibodies or immunoglobulins. Stimulation of the B cell by the specific antigen will lead to proliferation of the B cell and production of plasma cells. The plasma cells will synthesize immunoglobulins and secrete them. Antigen, abbreviated as AG. Antigen is a substance that reacts with its specific antibody. It is commonly immunogenic. Antigen usually stimulates the immune system to produce an immune response. Immunogenicity of an antigen. Immunogenicity is the ability of the antigen to induce an immune response. So it can be high or low. The extent of the immunogenicity depends on one foreignism. The more foreign the antigen, the higher the immunogenicity. 2. Molecular weight. The higher the molecular weight, the higher the immunogenicity. 3. Chemical complexity. The more the complexity of the antigen, the higher the immunogenicity. Physical nature. The antigen can be found as solid, fluid, or gas. Depending on the characteristic of the antigen, the immunogenicity will be. So one antigen in a solid state may give high immunogenicity, another one in fluid state may give high immunogenicity. Dose: how much of the antigen is given to give high immunogenicity? It is the optimum dose. The optimum dose is the enough dose, not more or less, just enough. The route, also, this is according to the antigen, the characteristics of the antigen. Some of the antigens may give high immune response, high immunogenicity through the oral route. Others may give high immunogenicity through the intradermal route. 7. Genetics: the genetic makeup of the person receiving the antigen. People differ in their genetic constitution, and also they differ in their response to antigenic stimulation. To the same antigen, different people respond differently. Now the lecture is over. I hope that it is understandable, and I wish you all the best.